Okay, here we're looking to simplify a sum of radicals, and we want to make sure that what's underneath the radical sign is in simplest form. We call this the radicand, so each one of these numbers is reduced as much as possible. So let's take a look at each one in turn. I'm going to start off with the first one here. Remember, we're looking for perfect square factors, in other words, numbers that divide nicely into the radicand and are perfect squares. So 72, right off the bat, I can see that it is the product of 36 and 2. So I'm going to write this as 12 root 36 times 2. And I'll keep going. So 4 and 52, 52, now 25 and 2 is 50, so 26 and 2 is 52. What about 4? Does 4 divide 52? Let's see, 48 is 12, yeah, 13. So we got 4 times 13 under the root sign. Let's write that again. So 117, that's equal to 9 and 13. So here we're going to have minus 5. Put that over there. Square root of 9 times 13. Finally, we have minus 4 square root of 9 times 2. Again, the numbers that we're looking at here are perfect squares, and we use those factors precisely because they're perfect squares. Because now, when we take this apart, I get 12 root 36 times root 2, and I'm dropping the explicit multiplication sign, 4 root 13 minus 5 root 9 root 13 minus 4 root 9 root 2. And let's simplify these guys here. So 12 times the root of 36 is 6 times root 2. 4 times the root of 4 is 2, and then I have root 13. 5, oops, times the square root of 9 is 3, root 13. 4 times the square root of 9, which is 3, root 2. And let's see, here we get 72, root 2, plus 8, root 3, minus 15, root 13, minus 12, root 2. And at this point, I'm just going to reorganize them. I mean, I can do that on an iPad, and bring this guy over here with the root 72 root 2, and just tag these guys on the end because, again, these have a common root term, these have a common root term, and I can add them together to give me 60 root 2 and negative 7 root 3. And I believe that, that is as simple as we can get.